figure out significant figures. And significant figures tells us how precise a measurement is. The significant figures in a measurement includes all digits that can be known precisely plus a last digit that is an estimate. Rules for significant figures. Any non-zero digit are significant. Any zeros between numbers are significant. Now, this is where it gets tricky. Zeros to the left, okay, of the first non-digit are not significant. So, for example, if you have a 0, 0, 0, 0, 1, all these zeros are not significant. Final zeros after the decimal are significant. So, for example, if we use this right here, 0.00010, this digit is significant. Zeros to the right of the last non-zero digit without a decimal point are not significant. So in other words, if we have 1, 0, 0, these two zeros are not significant. However, if there was a decimal place, then those zeros would be significant. Now, this is all important because when we use our calculators and we use some calculations, we have to figure out what our answer is going to be to the correct number of significant figures. Okay? This is important because oftentimes a calculator will give you a string of numbers. Okay? But I want you to be able to tell me by the end of this lesson, okay, your calculated answer should only have a certain number of significant figures, and you should be able to round to those numbers of significant figures. So, how many significant figures does each number have? According to the significant figure rules, all these numbers have 3. So, obviously, all 3 of those, since they're non-zero digits, are indicated as significant. Since this does not have a decimal point, these zeros do not count, so therefore it only has 3. Again, same thing as the first one. It doesn't have any zeros. And also this one. Again, because it only has non-zero digits and it doesn't include any zeros. This one does have zeros, but since there's a decimal point, then they are significant. And any leading zeros are not considered significant, so therefore they don't count. And there's these 3 non-zero digits. Here's a sample problem. Okay, go ahead and try to figure out how many significant figures based on the rules that I gave you. Pause the video and try to figure it out. Alright, so since these are all non-zero digits, you should have 3. These are all the digits here are significant because there's a decimal point, so therefore there are 6. Leading zeros, remember, never count, so there should be 2. Since there's no decimal point, these trailing zeros don't count, so there's 2. Again, leading zeros never count. Trailing zeros only count if there's a decimal, so there's 2. Leading zeros never count. Trailing zeros count only if there's a decimal, so there's 2. Leading zeros never count, so there's 3. Zeros in between numbers are always significant, so there's 5. Leading zeros never count, trailing zeros count if there is a decimal, so there's 4. And this one's a sandwich or in between numbers, so that always counts. Leading zeros never count, so there are 3. Zeros in between always count. Trailing zeros only count if there's a decimal, so there are 6. And again, trailing zeros only count if there's a decimal, so there's 4. So you should be able to do these problems and become more familiar, especially when you're doing calculations. So when you use your calculator, you need to be able to use the significant figures rule. Your final answer cannot be more precise than the original measurement. In other words, it cannot have more decimal places than the original numbers that you use. So, in multiplication or division, which are the rules you're most likely going to be using? So remember this rule. The number of significant figures in the result should equal the number of sig figs in the least precise number, or the number with the fewest number of significant digits. When you add or subtract, use the least number of decimal places in the original numbers being added or subtracted. So for example, if I am giving these problems, it asks me the number of sig figs or decimal places. Okay, since this is an addition or subtraction problem, I'm looking for the least number of decimal places, which is 2. The other one has 4. Okay, since this one, the next one, is a multiplication or division, I'm looking for significant figures. And I have 4 here and 5 there. So therefore my answer is going to have 4 significant figures. Again, the same holds true for the third one, where I'm looking for the smallest number of significant figures. This one has 5, this one has 4, so my answer should be in 4. Lastly, this one here, since there are 2, therefore my answer needs to be in 2 significant figures. And finally, we have an addition subtraction, and I'm looking for the least number of decimal places. Since there's 1, therefore my answer needs to be 1. Okay? Now you should be, since you figure out the number of sig figs, okay, you go ahead and punch those in your calculator, and you should get answers like this. But the correct answer needs to be in the number of decimal places or the number of sig figs. So since this is the number of decimal places, I need to round. Okay? And since this is 2 decimal places, what I do is I put a line, and if the digit right after the line is 5, I move the preceding digit up by 1. But since it's not, my answer is 4.28. The next one has to do with significant figures. And what I do is I count the number of significant figures. So this is my first, second, third, fourth. And I put a line. And again, I round up if the digit after the line is a 5. So my answer should be 47.94. Same holds true with this number here. Okay, I'm using the significant figures, so I count them. 1, 2, 3, 4. Line. Okay, and then I make a decision. 3.405. Significant figures. Okay, for the next one. And I count them. 1, 2, put a line. 2.2. And last one, I'm using decimal places. So I count the number of decimal places over, and therefore my answer should be 12.5. Now, you are to basically use these significant rules anytime there is a calculation. So, what I want you to do right now is to work on your worksheet, and it'll encompass all the concepts that I covered today.